Right, so this video is going to help you look at finding the derivative with first principles when fractions are involved. And as you can see from the questions that we've got here, this is without a point. So this is the formula that we're going to use, which gives us the derivative function. And we're just going to follow along. So what does this say here? Right, wherever x is in your function, replace it with x plus h. So we do exactly that which we've been doing all along. So instead of 1 over x, it's going to be 1 over x plus h. And then we minus the function itself, which is 1 over x, and we are dividing by h. Now, I'm not a big fan of having fractions over fractions, but what I'm going to ask you to do is, for now, just ignore that h at the bottom, okay? And focus on the fact that we have 1 over x plus h minus 1 over x. Now, you need to go back to remembering how to add and subtract fractions, okay? So if we had 3 over 7 take 1 over 2, right, what do? Well, the first thing we want to do is get that common denominator, and we do that by multiplying the denominators together. So we say 7 times 2 and we get 14. And you probably already know what comes next, but then we cross multiply. So we say 3 times 2 is 6 and 7 times 1 is 7, and then we can happily go along and add those together. Well, we're going to do exactly the same thing here. We are going to multiply our denominators together, and then we're going to cross multiply. Okay, so let's do that. So at the bottom, our denominator now becomes x times x plus h, and I'll just rewrite that a little bit because you'll see why in the next step. So that's going to be x. You think, why has she done that? It's the same thing. Yeah, it's about leaving a little gap at the front. And then we cross multiply, so 1 times x is x minus, and now we've got x plus h times 1, so we must make sure it's in brackets, otherwise that minus is going to play havoc. Now, remember I said ignore this divide by h. Well, now we include it. And because I am dividing by h, we pop that downstairs. All right, that's the little trick that can help ease a lot of these questions that we have. All right, and now the aim of the game is exactly the same as we had before. We want to eventually replace h with 0, but we can't do it until we pull out a common factor on the top line. So we simplify our top line, it becomes x. We're minusing x, and then we're minusing h, so we're expanding that bracket. Do not, I repeat, do not expand the denominator because it is already factorized for us. Okay, and remember, if we want to cancel stuff out, it has to be being multiplied together. Otherwise, we can't factorize. So x take x, they cancel out, so I'm left with minus h over h and x plus h. And this is looking pretty good because I can clearly cancel out this h from the top, this one from the bottom, and now I can make h equal to 0. So upstairs I've got minus 1 all over. Now h, right, that is now 0, so it's x times x, which is x squared. So therefore, f dashed of x, of 1 on x, is minus 1 over x squared. Or, if you like, minus x to the minus 2. And that fits one of our shortcut rules. So a couple of things to remember. Make sure your substitution is correct. Make sure that you cross multiply. We pop our h downstairs, but then everything else is the same. So let's try exactly the same with our next question. And I'm just going to write the rule. Okay, so a bit of a warning. This one might get a little bit uglier before it gets better, but let's give it a go. So again, what does this mean? It means wherever x is in your function, replace it with x plus h. So we've got 2 x's there. Now let's go along. Okay, so upstairs we have x plus h. And then downstairs we have 2 times x plus h plus 1. right, minus the function itself, so minus x all over 2x plus 1. And then we're dividing by h. So here we go. We are going to get our common denominator, and we do that by timesing the denominators together, and we are still dividing by h, so that just sits down at the bottom there. Okay, and then we're saying 2 times 2x plus h plus 1, so all of that is in a bracket, and we times that by the other denominator, which is 2x plus 1. And now we're going to cross multiply, so we end up with x plus h times 2x plus 1 minus x times 2 lots of x plus h. And you're just rewriting stuff, really. And I wish I had sort of done that on a fresh line, so I could have, or a fresh page, so I could have had not so squishy. But anyway, here we go. Limit. This is where we have our fingers crossed that we have done everything right. And so when I expand, all the stuff that doesn't have an h disappears. So expand the top bracket, and we've got 2x squared. Not confident this is all going to fit on this one line, but anyway, we proceed. Plus 2xh plus h minus, now, let's see this. 2 times x is 2x, but I'm timesing it by x, so that's going to be 2x squared. 2, so plus 2xh and plus x all over h. This is the painful bit, just rewriting everything, really. Notice, not expanding anything on the denominator. Don't expand it. It's all factorized nicely. So don't do it. Okay, let's have a look. What can I cancel here? Oops, we don't want to do that one because I want to keep using that. Yep. Okay, go with the green. Okay, so we've got a 2x squared here, which doesn't have an h, and lucky for us, there's a minus 2x squared there, so that works out well. This x, remember, minus this x here, that's going to cancel out. So that's nice. And what are we left with? I've got a 2xh. Oh, a minus 2xh. So they also cancel out. How sad, I've lost my green. And then I've got, oh, well, just h upstairs. All over, downstairs, we've got that monstrosity that I, yes, have to write again. So we've got h2x. Okay, we can see that, yes, we can cancel out our x's. Cancel out our h's there. Oops. And away we go. What we're left with, let's make h 0 now. So 1 is on the top line. Now when this h here is 0, I've got 2x plus 1 times another 2x plus 1. So isn't that nice? I've got 2x plus 1 all squared. Right, that's my f dashed of x. So just in case you couldn't see that, we'll just do it to the side so then I can erase it. We've got 1 on top. I've got 2. Oops. Thank you for disappearing. I've got 2x, but my h is 0. So that's 0 plus I've got the plus 1. So that's why that becomes 2x plus 1. And then I've got another 2x plus 1 there. So 2x plus 1 times 2x plus 1 gives me my 2x plus 1 all squared. And there she blows. That's how we get our first principles. Now, some of these ones, I mean, the first one we did, you can check that because we've got our rule that you can follow. But you don't actually have a rule that would work for this. So that's why first principles can be pretty handy. And next year you'll get some more rules that will help you. So with the first question, you could check that you were right using your shortcut rules. Okay, so we know that f of x is x to the minus 1, and so to find the derivative, f dashed of x, the minus 1 goes out the front, and then we take away 1 from the power, and we go, yep, that's correct, we're all good. But for this function, we don't have a rule for that, so how are we going to do it? Well, here's a bit of a tip. Choose a value for x. Okay, now when you've got a fraction, you need to make sure that you choose a value that won't make the denominator equal to 0. So how about 2? Right? If it's 2, the denominator will not be 0. So what I'm going to do is I am going to find f dashed of 2 on my calculator, right? We'll do that in a minute. And I'm going to check by subbing it into what I have here. So what do I have above? That would be 1 over, might as well do it as I've written it. It's going to be equal to 1 over 2 times 2 plus 1 squared. 2 times 2 is 4, plus 1 is 5, so 1 over 25. All right, so this is how we check on our calculator. Okay, sorry, just had to get that set up. So we go 1, we go option, calc, we hit dy by dx, and we can actually type in the function that we had right at the top. So what was that? That was x over 2x plus 1. So we'll just double check that that was x over 2x plus 1. Good. Okay, and of course we're choosing 2. Like, you could have chosen any value you wanted as long as you didn't make the denominator 0. And what we're hoping for is that we get the same answer. So bang, we know that we're right. That's just an easy way to check until you know the extra rules that you will eventually get. Hope that helps.